أهلا بكم طالبات وطلاب جريد 1 بريب. مع بعض هنبدأ درس جديد وحلقة جديدة في الماث تحت رعاية وإشراف وزارة التربية والتعليم. النهاردة درسنا هيكون عن operations، عن properties of operations of multiplication. سبق ودرسنا properties of addition in Q، وكان من أهمها Commutative Property و Associative Property و Identity Property، وعندنا كمان Properties more. خلينا نبدأ مع بعض أول درس. Properties of multiplication operation in Q. Closure property, the first one, the product of any two rational numbers is a rational number too. The second is commutative property, which is A times B equals B times A. The third, associative property, and here we have three numbers. We can start the multiplication from the first two numbers, then multiply it by the third, or start from the last two numbers, then multiply them by the first. 4. Multiplicative identity element property, which is A times 1 equals 1 times A equals A. So our element or our identity element is 1. Number 5. Multiplicative inverse property. The inverse is always we need to flip the fraction. We need to flip the fraction. So for example, if I have A over B, to get the inverse, we will write it as B over A. And keep in mind, when we multiply any rational number by its inverse, we will get 1, the identity property. Number 6 is distribution property. A times, and open brackets, B plus C or B minus C. We will distribute this A to multiply it by B, then multiply A and C. The same if we start the multiplication from left or from right, we will get the same answer. So here we have B plus or minus C times A. We can distribute this A to get B times A plus or minus C times A. Let's talk about each one of them. Closure property, as we said right now, the product of any two rational numbers is a rational number as well. So here we have Q is closed under multiplication operation. 2 over 5 times 3 over 11, both of them are rational numbers. And the product is 6 over 55, and it's a rational number too. Belongs to Q. Number 2, commutative property. We can switch the order. We can multiply A times B. They are equal to B times A. For example, if we have 3 over 5 times 1 over 7, we can write it as 1 over 7 times 3 over 5. And we need to evaluate the first side and evaluate the second side, then compare between them. We will get the same product. Here we have 3 over 35 in the first side, and in the second side also we have 3 over 35. Number 3, associative property. In associative property, we have three numbers, A, B, C. A times B, here we have brackets, then times C. We will take the first two numbers or take the last two numbers. Here, A times B first, get the product and multiply it by C. Or multiply B and C first, then get the product and multiply it by A. For example, we have 1 over 7 times 2 over 3 times 1 over 4. We have the same numbers, but what is the difference between them? In the first one, or in the first side, we will get the product of the first two numbers, which are 1 over 7 times 2 over 3. The product is 2 over 21, and then multiplied by 1 over 4, we will get 2 over 84. Let me remind you how to multiply fractions. we will multiply the numerators, then multiply the denominators. So 2 times 1 is 2, and 21 times 4 is 84. Now let's work on the second side. 1 over 7 multiplied by 2 over 3 times 1 over 4. We will start multiplying from 2 over 3 times 1 over 4. 2 times 1 is 2, and 3 times 4 is 12, then multiplied by 1 over 7. 1 times 2 is 2, and 7 times 12 is 84. As you can see, they are equal. After simplifying, we will get 1 over 42 for each side. So, number 4. The existence of multiplicative identity neutral element property. A times 1 is equal to 1 times A equals A. So, 1, when we multiply it by any number, we will get the same number if you multiply it from left or from right. For example, 3 over 5 times 1 is 3 over 5. What about 1 times 3 over 5? We will get the same product, which is 3 over 5. Number 5. The existence of multiplicative inverse of rational number property. For every rational number A over B except 0, we have to focus in this point, except 0. There is a multiplicative inverse, which is B over A. As you can see, we just flipped the fraction. We flipped it. A over B, it becomes B over A, where A over B times B over A equals 1. As we said it before, any number multiplied by its multiplicative inverse, we will get the identity property, which is 1. So, why we accept 0? Because 0, we can write it as 0 over 1. But when we flip it, it becomes 1 over 0. And as we know before, is undefined. 1 over 0 or any number over 0 is undefined. Number 6, property of distributing multiplication over addition and subtraction. A times brackets B plus or minus C, we will distribute this A. Here we have A times B plus or minus A times C. Do you see the two arrows? So we have to distribute this A for B and C. A times B plus or minus A times C. Then, if we start from the brackets and the A is to the right, also we will do the same. A times B and A times C. So, write them in order. B times A plus or minus C times A. Let's take exercises about it. 1 over 3 times brackets 7 over 10 plus 1 over 2. We will distribute this 1 over 3. We will multiply it by 7 over 10, then multiply it by 1/2. So as you can see, 1 over 3 times 7 over 10 plus 1 over 3 times half. To multiply fractions, we will multiply the numerators, then the denominators. 1 times 7 is 7, and 3 times 10 is 30. And then 1 times 1 is 1, 3 times 2 is 6. Now, which case do we have in addition? Do we have same denominator, convert one to the other, or cross multiplication? Let's have a look. We have 30 and 6. They are not the same. But my question is, can I convert 6 to be 30? Yes, of course. We will multiply it by 5. So we will multiply 1 over 6 by 5 up and down. 7 over 30 plus 1 over 6, then multiply it by 5 up and down. We will get 7 over 30 as it is, plus 1 times 5 is 5, 6 times 5 is 30. Then we will add 7 plus 5, which is 12, and put the same denominator, which is 30. Then simplify it by dividing it by 6 up and down. 12 divided by 6 is 2. 30 divided by 6 is 5. So the final answer is 2/5. Now, let's watch this video from the EKB.
You can solve any problem on multiplying rational numbers by using the properties of the multiplication operation in Q. Let's take a tour around some examples to discover how. In the shown example, find the value of the following and state the property. 12/13 times 4/11 plus 7/11 times 12/13 minus 12/13. Now let's solve the example. After using the distributing property, the problem will be 12/13 times 4/11 plus 7/11 minus 1, which equals 12/13 times 11/11 minus 1, which equals 12/13 times 1 minus 1, which equals 12/13 times 0, which equals 0.
To be clear for you, let's take more exercises. Number 1. If 2/5 times 1/9 equals n times 2/5, what do you observe? Actually, we switched the order. We started from 2/5 and then we start with n. So let's switch the order. n/5, we started from it. Now, in the second side, I put it at the second. So the missing number or the missing factor is 1/9 according to the commutative property. So we can switch the order. So n is equal to 1/9. Number 2. 1/3 times 4 minus 5/7. We will distribute this 1/3, 4 and 5/7. So 1/3 times 4 and 1/3 times 5/7. And we will keep this minus as it is. So the missing number is 5/7. Here we used which property? Distributing property. Number 3. 2/9 times m is equal to 2/9. Find 3m. Let's find the m first. Any number times what equals itself. So m is 1, identity property. 2/9 times 1 is equal to 2/9. But I need to get 3m. So we need to multiply 3 times 1, which is 3. Number 4. Find the multiplicative inverse for 2/3. As we said, we need to switch or to flip the fraction. It's written as 2/3. So when we flip it, it becomes 3/2. Let's solve some exercises on the glass board. Use distributing property to find that. Here we have 6/13 times 5/9 plus 6/13 times 4/9. As you can see, 6/13 is repeated, so we will write it and open brackets and cross it out. What is the factor here? We have 5/9 and put plus as it is. Then the other factor is 4/9. We need to find the addition first, then multiplied by 6/13 according to the order of operation. Start from the brackets. So we will write 6/13 as it is. Then, which case do we have? We have same denominator, so put it as it is. And then 5 plus 4 is 9. And 9 over 9 is 1, so write 6 over 13 as it is, and 1. By multiplication, any number times 1 is the same, so x over 13. The second question is for find the multiplicative inverse. To find the multiplicative inverse, we have to rewrite this mixed number to be improper fraction. So we need to multiply 5 times 2, then add 1. 5 times 2, then add 1 over 5. 5 times 2 is 10 plus 1 is 11 over 5. Now, how can we find the multiplicative inverse? We need to flip the fraction. So it's 5 over, it's 11 over 5. So we can write it as 5 over 11. And keep in mind, it's not allowed to keep 2 as it is, then flip 1 over 5. No, we have to rewrite any mixed number as a fraction or as improper fraction, then flip the improper fraction. That's all about it. Thank you so much. Now let's recap our lesson. Actually, we talked about the properties. What are the properties of multiplication operation? The first one is commutative property. We can switch the order. We can say A times B and B times A. They are equal. And then we talked about closure property. When we multiply any two rational numbers, we will get a rational number as well. So, if you have any number, even if we have integer, mixed number, a fraction, a decimal, any number belongs to Q. When we multiply it by a rational number, we will get a rational number too. Then, we talked about the commutative property and the associative property. Associative property means we have three numbers. We can multiply from the first two numbers, then get the product and multiply it by the third, or multiply the last two numbers, get the product and multiply it by the first one. Then we talked about the distributing property. We will distribute the multiplication over addition or subtraction. We can think about it as a visitor. So this visitor must shake hand for each one inside the home. For example, A times brackets B plus C. We will distribute this A, so A times B plus A times C. Even if this A becomes from left or it comes from right. Then we talked about the identity property, which is 1 in the multiplication. So 1 times any rational number is equal to the rational number, or the rational number times 1 equals the same number. Then we talked about the inverse, and here I need you to focus with me about the inverse. It's not allowed to get any inverse before rewriting it as a fraction. For example, if we have any mixed number as we did it right now on the glass board, 2 and 1 over 3, 2 and 1 over 5, any mixed number, we have to rename it or to rewrite it as an improper fraction. Multiply the denominator times the whole, then add the numerator. When we get it, flip it to get the multiplicative inverse. So it is not allowed to keep the whole as it is, then flip the fraction. No, we have to write it as an improper fraction, then flip it. So what about if I ask you to find the multiplicative inverse for a decimal? For example, if I have 0.4, how can we find the multiplicative inverse? As we said, we have to write it as a fraction. So 0.4, it has only one decimal place, so we will write it as 4 over 10. Then let's flip it. It becomes 10 over 4. So here I need you to focus with me about the mixed number and the decimals. We have to rewrite them as a fraction. The mixed number, we will write it as an improper fraction. The decimal, we will write it as a fraction. Then flip it if we need to get the multiplicative inverse. That's all about the 6 properties. Thank you so much. Let me see you next time. Bye-bye.